So 3 safety indoor air quality, gas, and electrical hazards. So indoor air quality, what is the right approach? Studies of comprehensive energy, health, and safety retrofit programs found that for children with asthma, hospital admissions fell by nearly 85% and emergency visits by 68% a year after the upgrade. So what they're talking about is tightening of the home, trying to separate the house from the external environment. You want to think of your we call it the thermal envelope or the building shell. It's your walls, the ceiling above your head, the floor below you. If you can tighten that and control those environments, then you're less likely to have issues with pollen from outside. You might open the door, there might be a gust of wind and the window's open or something like that. You can control that now. But if you've got a leaky house that's poorly air sealed and poorly insulated, especially air sealed, it's just like having a window wide open. And for the majority of houses, say like if you've got a turn of the century, late 1800s to like 1930s, when there's balloon framing still, those houses on average leak 300% per hour, meaning every 20%, 100% of the volume of air energy in that house is transferring somehow with the outside. So that's a lot of volume, and that's impossible at times for anything like heating and cooling to counteract that. It's great back in the day when everybody had gravity furnaces and fuel was abundant. You just have that thing running 24 hours a day, but we don't do that anymore. We can't afford that. So that's why we're going towards more efficient and more effective systems. Again, so the indoor air quality system here, I think what's going on is there's like, let's see here, there we go.
You just scroll, yeah.
There we go, how bizarre.
It's a okay. Transition, so yeah, it's kind of feeding in as you go. So
I'll check that next time.
Yeah.
So indoor air quality issues. Indoor air quality is 2 to 5 times worse than outdoor air quality, according to EPA. So how does that happen? Well, if your house is leaky, there's not a whole lot of air movement in there besides your body's moving or by maybe a fan going on or AC or furnace going on. That's what's moving the energy. But if there's no filtration or you're not getting fresh air from outside that's being filtered and pushing old air back outside, that's how inside air qualities can get pretty bad. Also materials in new houses in the 80s, 70s, we had formaldehyde. That is still an issue for a lot of homes, a lot of leakage from that. Radon is a major issue that still has to do with indoor air quality. There's a lot of things, mold, condensation issues, a lot of things that can make the indoor air quality worse because it just doesn't get out. It can become clear 5 minutes later after it's smoky outside and your house is still smoky. We spend 90% of the day in buildings. I think this number may have gone up since we're all working remotely from home. Children and older adults are more susceptible, pretty much self-explanatory. So if you have people with medical conditions, anyone that's affected or sensitive to allergens, these are things that you want to focus on as indoor air quality. And how to diagnose, duct blaster test. So if you turn on your furnace, or you turn on your AC in the summertime, HVAC is a closed loop that is connected to your internal environment. It should not in any way, unless it's connected to a specific type of system, it shouldn't be allowing smoke from outside or allergens from coming into that pathway. If it's a tight duct system connected to a tight furnace or air handler, and the registers are tight, it's pushing the air into your environment. It's pulling the air from that environment back to the return and back into the system into a continuous loop. If people turn on the furnace or the HVAC and they say suddenly the place gets smoky, it's a good chance that you've got a leak somewhere in your duct system. And people think that with, well, here's an example. If you take a straw here, right? And you've all had like bendy straws, you've been young and had a bendy saw and it's had a cut in it. And you go to draw liquid through it and it's drawing air into that straw from that hole because you've got static pressure from the liquid below, and it's easier to draw the air into that space while you've got suction on it. Same thing happens with a duct system. You've got air passing through it, and you might get a little gap. And instead of it pushing air out of that, the velocity creates what's called venturi, and it instead sucks air in through that gap. And that's where we get a lot of dust. So people will say every time we turn on the AC in the summertime, there's tons of dust that comes out from the vents. Check your duct system, get it duct tested, get a pressure test on it. If they come back, say it's leaky, the majority of homeowners, if all they do is duct sealing, it's about a $500 upgrade. It usually accounts for about 15 to 30% of total house leakage if you have a central air system. So it's pretty drastic if you can just seal the ductwork. Indoor air quality tests, it's totally worthwhile to go to a specialist that has a machine like the one shown here. They cost anywhere from $4,000, I've heard, to like $12,000. Some of them are very intricate, where you have more like a computer with you, and it can look at thousands of different types of parts per million particulates. Something like this here is looking more at carbon monoxide, carbon dioxide. It's looking at anything that's most likely an off-gassing residential issue, and that's what they're looking at here. So it kind of gives the homeowner a quick idea. Somebody could walk around with this device and say, okay, we are getting pretty high parts per million for CO2, for carbon monoxide. So we know that for some reason, you've got a gas issue. You've got a gas leak, or you've got a carbon monoxide leak. Maybe they go through here and they've got a test for indoor air quality for mold spore. That's very possible. And they can tell right away, you've got this type of mold, that kind of mold, or it can go be analyzed for more in-depth understanding. That can be sent to a doctor, and then suddenly you know this is what's affecting you or your family. Blower door test, that's gonna test the overall leakage of the home. So you're gonna get a blower door test, or if you get one done, they put this big thing on your front door. They close all your windows and doors. They turn off the bathroom fans. They turn off the gas devices, make sure those can't turn on. They put this big fan on the front there. They turn it on at 50 Pascal. They do the math and they say all the leakage, all the gaps, and everything in your house, if we combine that all, you're looking at 144 square inches, or 1 by 1 foot. And that's pretty typical. The woman's house I spoke about today, her energy audit was 77 inches square. So maybe 8 by 8 or 8 by 7 or so is this hole. If you take all that accumulated holes through your outlets, around your windows and doors, through those top plates, bypass leakages through electrical plumbing, through your floor, ventilation, take all that gappage, combine it. That's your goal. You've got this square now, and your goal is to make it smaller, right? And the more you tighten it, the more control you have over retaining energy and sustaining temperature. Thermal imaging is something that's pretty fun. So if you get if you get a blower door test done, probably worthwhile to get an energy audit done. Those are comprehensive, and they do thermal imaging. They can take a photograph and tell you exactly where air is leaking into the house. You could have all brand new windows, swear that they're brand new, but you think that there's leakage around it. Maybe they just didn't install it into the framing correctly, and it's leaking from the outside molding right through the frame and right into the house. The tops and bottoms of windows and doors, or the tops and bottoms of windows, are not usually easy to see. You might be able to run your fingers along those sections. You might actually feel a gap behind that area right into the wall. And it's not sealed or molded sometimes because it's aesthetically, you can't see it, so it doesn't matter. The left and right side of windows and doors, yes, they're caulked nicely, they're painted nicely, trimmed nicely, but the tops and bottoms of windows and doors, or windows and the tops of doors, that's where we see a ton of leakage, and it's kind of crazy. So it's something you can kind of look at. Let's see here.
Jason? Quick, those tests, about how much are they? We're kind of running late on time, but how much are those tests in general? Kind of just a ballpark.
Yeah, totally. And thanks for telling me about the time. This is
It's
kind of a
really
long one here.
interesting stuff. So, yeah.
So duct blaster test, probably 2,000 square foot house. That's kind of what we base everything on. 350 to 750. If you're paying the higher range, I would ask the auditor what the cost is for a comprehensive energy audit, because a comprehensive energy audit will typically include all three of these things. They'll usually do a duct blaster test or duct test. They'll usually do some form of an indoor air quality test, even just for if anything, carbon monoxide from gas producing devices. Blower door tests, alone, you might be able to get one for $150 to $200.
So
And
comprehensive is how much?
Comprehensive energy audit with everything. If you're South Bay, San Mateo, if you're using like Elements 03 Energy, I can get their information. They're $1,000 minimum, and it's a 4 to 6 hour long visit, and it will completely pinpoint exactly what part of the wall, what part of the house, what part of the floor, what window, what door, anything you can imagine. It will completely pinpoint where your issues are and prioritize what to do. So those costs, I'd say the average would be $500 to $1,250. So all across the Bay, you might find an auditor that will do a blower door test, duct blaster test, some sort of air quality test for about $500. But it can go $750 to $1,250 is kind of more typical, I'd say.
Okay.
Let's see here. These are, I'll go real quick. Electrify your gas water heater or furnace, floor furnace here. We got a wall furnace on the right. Got a typical stand-up upright furnace in the center. The weird-looking gnome thing on the bottom there, that is a 1916 Rude on-demand water heater that I'm working with a homeowner right now in Oakland to try to replace. And it's technically a gravity water heater, meaning that the water is always constantly running through hot water pipes without a pump. It's just using hot water to do that. And the problem with replacing this is that you basically need all brand new plumbing. It's plumbed basically like a radiator is. And then on the left here, you can see old gas water heater, trying to replace that and upgrade it to say heat pump technology. These are those options. Some different types of gas devices, pool heaters, real common, gas hogs. They now have solar thermal, which is very popular and becoming more popularized. Evacuated tube, probably the best way to go. Most cost effective, super hot water. They can even use that solar thermal to pipe to a hot water tank, and the pool can actually feed off that tank because the tank is kept at a hotter temperature, let's say 140, 160 degrees. That's mixed in with cool water from the tap that goes to the pool or that goes to consume for domestic hot water. So these are those solar thermals, $4,000 minimum, usually to get incorporated into the house. This is on the left there is a heat pump water heater for a pool. And honestly, they're like 110 volt, major good replacement. And I've had really happy things. People said really good things about them. We don't really focus on them, but I'd say about $2,000 to $3,000 installed is what people are getting them for. So it's a pretty good deal. Boilers, there's something called split water heaters, split boilers. So this heat pump sits outside. This big box at the top here is replaced with this tiny box. And instead of having a gas producing device inside the house or hearing a mechanism in the home, all you've got is your pipes connected to it, manifolds, whatever it might be, radiant, whatever you're trying to do. And then the heat source is outside, extracting energy from outside and converting it to hot water. Cooktop ranges, old gas ones. We do get a lot of people that have old school antique gas cooktops that they want to keep. Yes, there are companies throughout the country that will convert those to induction or to electric. It's costly, but it's definitely worthwhile for some people that are trying to reuse things. The bottom image there would be an induction cooktop or induction range. And the number one complaint, don't get an air fryer with a range because they're hard to clean out. Just get the regular convection electric or steam. Fireplace inserts, the bottom image is interesting. That is a water vapor heater, and it heats with electric element, about 1,500 watts usually. These go anywhere from about $4,000 to $8,000 installed. And you can look up on Google Images, water vapor fireplace, and you'll see a huge assortment. They come in any color you can imagine, because it's just an LED that shines on multiple layers of water vapor that comes up, and they're awesome. They are not a fire hazard. They don't produce any carbon monoxide, and you get a little heat if you get the ones with, say, a heating element in them. And to say that any fireplace really shouldn't be used as a heat source. It's more of a space to drink coffee, read a book, have family over, but it shouldn't be seen as a heat source because the majority of it goes right up through the chimney. So it's not a good idea. Comfort, our experiences and possible expectations. I'll try to cruise through this. So this is basically 3 sections. Our experiences, unexplained drafts, indoor air pollutants, wearing extra clothes, temperature imbalance. That can be solved by air sealing and insulation, retain, sustain. Unsafe carbon levels, carbon monoxide levels, seasonal headaches, moisture control, hazards testing, indoor air quality testing. Complaining family members, happens to every family I talk to, high energy bills, totally confused, talk to us. Reach out to us or get an energy audit. We'll send you an example of those. You can figure out what you want to do, how you want to start. Again, you're annoyed by long hot water times, running out of hot water, probably has to do with water heating sizing, and it could be easily fixed sometimes with a $500 scheduled recirculator, especially if your water heater is not too old. And old is anything above 15. You're doing great. 1916 blew us away, but anything over 15, you're getting close. If you've never maintained it, most people scratch their head. What do you mean maintain a water heater? Every 2 to 3 years, if you have a tank or an on-demand, every 2 to 3 years, you should have a company come out, or you can look online to do it yourself, clean out, drain the water, exchange or change out the anode rod that looks like a link of sausages. It comes out from the top of the water heater. It's replaced. They cost about $50, maybe $200 every 2 to 3 years. And the water heater should last 15 to 20 years without any major issues. So again, our expectations, attic insulation or insulation air sealing, what needs we can meet, what we want to happen, fresh air to breathe. We all want that. We want controlled indoor air pollutants. Instead of wearing extra clothes on, we want to be able to run around our house naked, right? Anybody should be able to do it. You should be able to be comfortable, not worry about extra clothes, extra socks, or stripping down in the middle of the summer because you're too hot. Year-round comfort, that should be a need that should be easily be able to be met. 0 carbon monoxide levels with hazard testing, indoor air quality testing. Hopefully the end result, 0 carbon monoxide levels. You don't want to have any of that. Hopefully you have more seasonal allergen control, more humidity control. And humidity is going to be an issue if you've got a fish tank. If you've got a lot of plants, you're going to have to figure out a way to kind of counteract that stuff. Energy advising, hopefully at the end of it, you don't have any more complaints. If you do, you're going to have to deal with it some other way, I guess. Building a below average energy bills, again, a 2,000 square foot house, easy to get $50 a month or so, $75 a month, not unheard of per month for gas, electric combined. And that's to live comfortably. That's people keeping their temperature set at 72 in the winter and never having to adjust the thermostat, never having to turn it off or override it because the house can retain and sustain. Water sizing, scheduled recirculator, 0 hot water wait times. You're not wasting any water waiting for that hot water to get there. And you got plenty of hot water, especially if you've got a tank that's oversized, overheated, and you're using something like a thermostatic mixing valve.